All right, we're back. We're on page 6 of the Calc AB Notes 6, Implicit Differentiation. There's a big thunderstorm going on outside. I don't know if my mic picks that up or not. I got a lamp on because it's so dark in here in the middle of the day. But, you know, we're doing problems, so it's not that bad. So what are we doing here? So these notes are all about implicit differentiation. And yet here I find myself finding the derivatives of inverse trig functions. That's a little weird. So let's see what this is talking about. So why would we think of these as things we could use implicit on? Well, we start with y equals sine inverse of x. If that is true, then I can take the sine of both sides, and it'll be the sine of y is equal to the sine of sine inverse of x. But the sine of sine inverse of x is just x. So the sine of y equals x. Okay. Now the next part says, draw a triangle representing this relationship. What does that mean? This is, if you had me for math analysis, this is one of my favorite types of problems where you take a ratio and you draw a triangle and then use a triangle to like do stuff. So I'm going to draw a triangle. I'm going to try to draw a triangle. Okay, I think that's a pretty good triangle. I mean, you know, the app did all the work, but I still think it's good. So sine is equal to x, so x over 1. So if this is the angle y, then this would be opposite is x, hypotenuse is 1. Okay, so what's missing? The missing side is the square root of 1 minus x squared. All right, not bad. Now, the next part says, find dy dx implicitly. So I'm going to find the derivative with respect to x of sine of y and the derivative with respect to x of x, you know, pretty clearly. So the derivative of sine of something is cosine of that thing. So cosine of y times the derivative of that thing. Y is a function of x, so times dy dx, chain rule, and then 1. So then dy dx is 1 over the cosine of y, which you might prefer to write as secant of y, right? Because 1 over cosine is secant. I don't really think it benefits you all that much in this particular case to do that, but you could if you wanted to. Now, the original problem that we were dealing with, we had y is a function of x. So if we can avoid it, we would like to write our derivative not in terms of y, but in terms of x. It turns out we can do that. The reason we can do that is if we go back to our triangle up here, we can use this triangle to actually find the cosine of y, right? So based on the triangle, cosine of y, I don't know how to get this all on one thing. I'm going to do it over here. Cosine of y in this triangle is adjacent, which is root 1 minus x squared, over hypotenuse, or it's just radical 1 minus x squared. So cosine is radical 1 minus, cosine of y is radical 1 minus x squared. And so dy dx, oh God, that's a partial derivative symbol. We don't even know what that means. Also, I can't get rid of it. What the heck? Go away. Okay, there we go. Whew, that's like 2 years from now, or several semesters, one of those. Dy dx, 1 over, okay, so we're replacing this with this because we want to write our answer in terms of x. So over square root 1 minus x squared. And that's our answer. So it says to box it. So let's do that. It's like I'm not patient enough to wait for the lines to like snap in. Box in. I wonder how bad a line you can make for it to like not do that. But anyway, so really what I'd prefer to write is that d dx of sine inverse is equal to 1 over radical 1 minus x squared. I think you need to memorize that. You're going to use it a ton. It comes up a lot, and you're going to want to be able to go backwards. When you see 1 over radical 1 minus x, you want to look at that and be like, I know that that's the derivative of arcsine. Start memorizing that like immediately. All right, I'm going to do these three It's like the same process, so I'm gonna do them like relatively quickly. Who knows? Every time I say that, things don't go that great. So here we're gonna have the cosine of y is equal to x. So we can draw a triangle. I'll draw a bad triangle. Speed it along, you know? Here's x, here's 1, square root of 1 minus x squared, and then this is the angle y. All right, a derivative. So it's the negative sine of y dy dx is equal to 1, which means dy dx is negative 1 over the sine of y. Now, you might want to write that as cosecant. If you do it. Not a problem. I don't want to write my answer in terms of y, though. So I go to my triangle, and on the triangle, I look for sine. So sine is this over this. So the sine of y is going to be, oh, I'm writing all over the place. I just realized I'm not supposed to write here. Like this. So my final answer is d dx of cosine inverse, of x is equal to negative 1 over radical 1 minus x squared. Now, what do you notice about that? That's freaky, because we got this for the derivative of arccosine. The derivative of arcsine was the same, but positive. So that's really interesting. A cofunction, an inverse cofunction, has picked up a negative sign, just like the normal cofunctions pick up a negative sign. So the question becomes, like, is that a thing? Like, is that going to keep happening? So let's see, how much can I move things over? Move this over here, and then maybe move everything like a little tiny bit over. All right. How much space do I have? Not a lot. All right, here we go. So I'm just going to I'll do tangent, and then we'll guess cotangent, because I bet we can. So the tangent of y is equal to x. We draw a triangle. So tangent, opposite, adjacent, what's missing? Radical 1 plus x squared. Okay, and this would have to be y. So the derivative of tangent is secant squared of the thing times the derivative, so times dy dx equals 1. Okay, so far so good. Dy dx is going to be 1 over secant squared. I'm going to write that as cosine squared. So cosine squared of y. Okay, so now we go up to the triangle, and we say, in this triangle, the cosine of y is 1 over the square root of 1 plus x squared. Okay, how does that help us? Well, we have, I wish I had more colors that I liked using. We have the cosine of y is this, and we're dealing with this. So we can say that the derivative, so d dx, of, what do we find the derivative? Arctan of x is, in terms of x, 1 over 1 plus x squared. This is my favorite one. It's my favorite one because this one comes up like everywhere. There's no excuses. You got to know this one, forward and backward. This one, arcsine. Honestly, the co-derivatives are like not that important. Not that you shouldn't know them, but all of the co's just pick up a negative. So if I do inverse cotangent, I'm just going to write it down. The derivative with respect to x of cotan, what? Get out. Nobody wants that. Of cotan inverse of x is actually equal to, I'm doing this way too close to the side. Can I move things? Go over here, and then you go maybe over here also. Okay, so the derivative of cotangent is actually of cotan inverse, arccotangent. I don't know what you say there. I say tan inverse, arctan. I guess I go back and forth. I don't know. Anyway, the derivative of arccotangent is going to be negative, and I have no marker, negative 1 over 1 plus x squared. It turns out that just like with the normal trig functions, the derivatives of the inverses, if it's a co, it's got a negative in front of it. So this is definitely worth knowing, but let me tell you, you will use arcsine and arctan all the time. You will almost never use arccosine, almost never use arccotan. Arcsecant, we're going to do in the next thing. But anyway, does the cos thing still happen here? Yes, it does. Yes, it does. Let's go with 3. Very excited about that. Okay, so what I'm going to do is I'm going to stop this here. You need to memorize these, right? So the derivative of arcsine is 1 over the square root of 1 minus x squared. The derivative of arctangent is 1 over 1 plus x squared. The derivatives of the cos are just negatives. So arccosine is negative 1 over square root of 1 minus x squared. Arccotan is negative 1 over negative 1 time, negative 1 over 1 plus x squared. Negative 1 times 1 over 1 plus x, they're all the same. Okay, so I'm going to cut this here. I'll be back in the next video, talk about arcsecant, which is weird. So I will see you there.